Number 4, from rational functions, number 2, we're graphing this without the assistance of a graphing calculator. Notice that the degree on top is a 2 and the degree on the bottom is a 1. And so I already know that we are going to have a slant asymptote, also known as an oblique asymptote. When that occurs, there is no horizontal asymptote. So let's figure that out by going down to the bottom where I have a little more space. I have x squared. Now notice there is no middle term, so plus 0x plus 16. What I'm trying to show you is that every place must be represented. So if we start with a degree of 2, then 2, 1, and 0 must be represented. So x to the second, x to the first was not in this portion of the numerator, so I need to add in a 0x, and then x to the 0. So x to the second, x to the first, and x to the 0. On the outside, the highest value on a variable is a 1 in the x1 position, so this is degree 1. So here we go, degree 1 and degree 0. Okay, let's get started here. So when I think about graphing this, the very first thing I'm going to do, let me move. Okay, when I do this, I'm going to underline the first, my little lines down, and I'll underline this, and I'm asking myself 2x times what quantity equals x squared? Well, I can see that this quantity that I'm going to choose needs an x to raise up to x squared, but I want the leading coefficient to be a 1, and I have a 2. If I take half of 2, I end up with 1. This is my selected quantity, so in the column that only contains x's, I'm going to write 1/2 x. Multiply half of 2 is 1, and I have an x squared. Half of 4 is 2. Make sure to bring down the negative sign, and I have an x. Change the signs in the second row, and I have 0x squared. That cancels out, and 0 and 2 is 2x plus 16. Underline and underline. 2x times what is 2x plus 1. Multiply to get 2x, multiply to get -4. Change the signs and add down. And as I shared with you during 0 hour, that when you have a remainder and we're trying to find the slant asymptote, the remainder doesn't mean anything for slant asymptote. The equation of the slant asymptote is y equals 1/2 x plus 1. So I'm going to go ahead at this time and I'm going to graph that. So I start at 1 and I'm going up 1 and over 2. Up 1 and over 2, and I'm going to do that throughout the graph. And then I'm going to go down 1 and over 2. Okay, let's now identify the equation of the vertical asymptote. So the vertical asymptote, I'm going to take the denominator, I'm going to set it equal and solve. I'm adding 4 to the opposite side, dividing by 2, and I get an equation of x equals 2. That is going to be the vertical asymptote. Okay, let's go ahead now. Let's identify what the y-intercept is. So when I'm finding the y-intercept, x is always 0. So when I replace 0 into the original equation, into this x, and down below I have 16 over -4. 16 divided by -4 is -4. So here's 0, 1, 2, 3, 4. I'm going to grab a different color so it stands out. This is the y-intercept. And now for the x-intercepts, if we have a variable in the numerator, I'm going to take that numerator and I'm going to set it equal to 0 and I'm going to solve. So I'm going to subtract 16 to the opposite side. I take the square root. I want to have 2 answers, plus or minus. We can't take the square root of a negative, comes outside as an I, and I have x equals plus or minus 4i. So imaginary numbers do not go on this graph. This is only showing real numbers. We have an x and y axis here in this Cartesian plane. So what does this tell me? It tells me that when I solve, if there's a variable in the numerator, if I solve and I get an I answer, that particular one means that there is no x-intercept. Okay, so I can see this is coming down. It's going to get closer and closer, never going to touch the x-axis. And then just based on doing so many problems, we can predict it's going to be up here. But we do want to show appropriate values when necessary. So I'm going to choose one number to the right. So I'm going to choose x equals 3. One number to the right of this, and I'm going to plug this in. 3 squared, so my output here, 3 squared is 9. 9 plus 16 is 25. 2 times 3 is 6. 6 subtract 4 is 2. Now what's half of 25 is 13.5. That's the output to when x is equal to 3. So I know I only go up 10 here, so here's 3. I believe I'm up 10. 2, 4, 6, 8, 10, yes. So I'm up here at 10, 11, 12, 13, 13 and a half, somewhere up in that position. And I'm going to come down and back out again.